All right. Come on. You guys see that okay? Yeah, it's all right?
Yes.
Cool. Thank you. Okay, so so the biggest thing that I saw that that will lose points for people is not submitting work. So I was pretty generous, and I tried as much as I could to send you nagging messages multiple times to let you know that you needed to submit the work. If you weren't able to do that, that's fine, but just bear in mind for future quizzes that if you don't submit your work, you will always lose points for that. Now, that being said, there are some problems that don't require work, right? But anything that's dimensional analysis related will. And then in terms of what work you're showing, I think there was also some bummed out people about having solved it in a slightly different way than we do. The whole point of teaching the dimensional analysis technique is that we wanted to make sure that you guys have this tool of how to problem solve and that you're practicing that, right? So are there other ways to solve these problems? Of course, there's so many different ways that you guys could be solving these problems, but I want you guys to give dimensional analysis a chance. So that was the other thing, is if you didn't show your work, in some kind of unit arranging fashion, then you lost a little bit of credit for that as well. And then please, next time, if you didn't submit a PDF, I'm going to take off a point from quizzes for future reference for images. It's not a super big deal, but it's just kind of a pain because I have to download all of those submissions, and it makes it a little bit easier if it's a PDF. So if you guys can do that, that'd be awesome. It looked like some people were struggling again with the dimensional analysis setup. A couple of people I saw still had their sino backwards, so having negative exponents be really big numbers or positive exponents be really small numbers. Taking smaller steps. So I did see some people were trying to use conversion factors that I was a little bit confused about how they got. But I think generally smaller steps tend to be better because it's easier to make mistakes when you try and stick steps together, if that makes sense. And then the other thing I saw was calculator issues. So people still not quite sure how to put scientific notation in their calculator, or just generally how their calculator functions. So those were the things that I saw. What kind of questions do you guys have?
Did you already go over the answers for each question?
Nope. There's multiple versions for each quiz. So ideally, if you guys want to open up your quiz and take a look and see which questions you are struggling with, let me know which ones, and then we can do them together, or I can address specific questions that you have about them. Does that make sense?
Yes. If you can
Go ahead.
Go ahead. If you can go over number 2, that would be great. That one, I feel that one took me forever, and I was very lost. I thought I watched the videos, but I don't know. I feel something's way off, and I think that one, my answer was completely off.
Daniela, you were the Wednesday afternoon class.
Correct.
And can you just remind me what that problem was?
Let me see if I can show it to you. Can you see it? This is number 2.
Yeah, so okay, cool. So we've got 7.44 times 10 to the negative 9 kiloliters to milliliters. Yeah, absolutely, we can do that. So this was one where specifically I saw people trying to make big leaps, and where that gets dangerous, right? So the big one with this, the thing that makes this difficult is the fact that you guys have to memorize these conversion factors, right? So just starting off with looking at kiloliters, right? Is that a big unit or a small unit? Can't hear you, Danielle. It's a big unit, right? Is everybody comfortable with that? So if
Yeah,
that...
I know. For me, it got confused. I knew it was a big unit, but
Mhm.
because of the -9, we always said that those negatives always are assumed to be a very, very tiny number. So that's,
Yes.
I think, where my confusion is at.
Sure. Sure. Okay, so that's good. Let's talk about that. So this is absolutely a very small number, right? So very small number in a big unit, right? And now we're trying to get it into a small unit. Sorry, you guys, for my constant alerts. We're trying to get it into a much smaller unit, right? Is everybody with me on that? So if I know I have a very small number in a big unit, right, and I'm going to a smaller unit, should this number get bigger or smaller?
Smaller?
It should get bigger, right? So it looks really small because it's in these gigantic units, right? So in the same way that a toddler would look really small in your clothes, right? Same kind of concept here. But when you put on the clothes, then they look normal sized, right? Does that kind of make sense? So if this is a really small number and a really big unit, right? If I'm moving to a smaller unit, then this number should look bigger, right? Now, relatively speaking, bigger compared to 10 to the negative 9th, right? It still may be a small number. Does that make sense? So it doesn't mean it's going to be a positive exponent. It just means that we expect that the exponent is going to get less negative. Is everybody okay with that? Questions? Cool. So, first thing I like to do with these problems is map them out. So, I'm not going to go straight from kiloliters to milliliters. That's too big of a jump for me. So I'm going to first go to liters, and then I'll go to milliliters, right? So what is the conversion factor that I need to go from kiloliters to liters?
Is it 1 liter is 1,000 kiloliters?
It is not.
Okay, is it opposite?
It's the opposite, yeah. So
I do that, and I
no,
know it.
no worries. So again, kiloliter, kilo's the big guy, right? So we know that there must be a lot of the little guy in the big guy, right? So everybody comfortable with that? That was definitely the most common mistake, was inverting these, right? So accidentally putting the 10 to the 3 with this guy. But if this is the bigger unit, then it should contain more of the smaller unit, right? So then thinking about going from liters to milliliters, which one is the bigger unit there?
Liters.
liters, right? So we should have 1 liter for every 1,000
1,000.
milliliters.
And I had that thought right. Yeah.
No worries, no worries. And I think there's a lot of second guessing, right? Anytime there's memorization involved. I saw some people had this and then scratched it out, right? We're like, oh, just kidding. No, it's only 100, or So I get it. It's definitely, it takes some practice to get comfortable with these, but I would say arguably this was the hardest of the problems because you had to have both of these factors memorized in order to get the whole problem, right? So then now we can set up our dimensional analysis and our railroad tracks. And we have kiloliters to start. So what unit are we going to want on bottom?
Kiloliters, because we're trying to get rid of it.
Exactly.
We're trying to get rid of it. Goes on the bottom?
Exactly. So specifically, the unit, the conversion factor that we have has 1 kiloliter, right? And then also has 1,000 liters, right?
And a quick question, will you always use the railroad track, like the 7.44 on top? Will that always be on top, or can you do it on the bottom?
So this is really flexible. It's all about how things work out to cancel. Does that make sense? So it doesn't really matter where these things are, whether they're on the top or the bottom of the railroad track. The point of the whole exercise is to make sure that whatever unit you want to get to is the only unit that you end up with, and that it's in the top, in the numerator. Does that answer your question?
Yeah.
Cool.
Thank you.
Oh yeah, sorry, Abdi, I missed that question. It will be available on campus, yes. Okay, so everybody comfortable with that step? Cool. So then, now we're in liters, right? So now we need to make our next jump. What unit should be on the bottom?
Liters.
So for every 1 liter, I have 1,000 milliliters, exactly. Right, so now my liters cancel. So now at this point, I think it's helpful to rewrite this without all of the messiness of all the units, and to summarize what you're going to put in your calculator, right? So in our denominator here, the other thing that I saw people doing was anything that has this line between it is being multiplied together, right? So this is multiplication happening. 1 times 1 equals 1, no big deal. But here, 1,000 times 1,000, we're not adding those. That was one thing that I saw people doing. So they're not additive, they're multiplied, right? So just make sure you guys are multiplying all these guys together. And then anything that's on the top is multiplied together first, and then everything in the denominator, right, is being multiplied together and then divided into the numerator. So here I have, personally, I like the Sino way because I'm very prone to making mistakes out of Sino because all these zeros floating around get me confused. But if you prefer to try and take it out of Sino and do it that way, that's also fine. But eventually you're going to need to know how to do Sino, so I would just recommend that you try and practice that. So if I have 2 powers of 10 being multiplied together, how do I combine those exponents? They're additive, right? So if I have 10 to the 3 times 10 to the 3, right? What does that equal to?
10 to the 6.
Is everybody comfortable with that? 10 to the 6th?
Yes.
So we have 10 to the 6th for for this guy, right? And then when we add -9 and 6, what do we get?
-3.
-3. Everybody okay with that? So we end up with 7.44 times 10 to the -3 milliliters. Okay? So what was the part you guys would say that you struggle with on this particular problem?
I had a different version, but I think that because I went from kilograms to milligrams and I only multiplied it by 1,000, so either I got the conversion wrong or I didn't multiply it enough times. I think that's where.
So one of the common things that I see students doing is they try to make this direct jump. I'm sorry, I'm off the map now. They try to make this direct jump, right?
Yeah, that's what I did.
And you always want to, if you have a base unit in between, right? So kiloliters is, let me write this down. Can I erase? It's okay? We're good?
Yeah.
Cool. So in terms of where our units are, we have kilo, and then the base unit, which was liters, and then we had milliliters, right? So anytime you're starting out up here, right, you always want to go to the base unit first and then go down below. Does that make sense, Angelique?
Yes, but kind of. So in the case of kilograms to milligrams,
Mm-hmm.
would I go? I just want to see if I would know how to do it now.
So again, for every 1 kiloliter, right,
Okay.
there's 10 to the 3 liters,
Okay.
right? And
Yeah.
for every 1 liter, there's 10 to the 3 milliliters, right?
Yeah.
So you have 2,000-fold jumps that you have to make in this calculation, right? I'm really visual, so like having this written down, or like being able to see these kinds of things really helps me be able to organize the information. So I don't know if that's helpful to you, but that really helps me.
Okay.
So not just memorizing the numbers, but memorizing like the order, right? So you can think of this as being the highest or the biggest, right? And then a little bit lower, and then a little bit lower, and then a little bit lower. Does that kind of make sense? No problem, Juan. Any other questions you guys have about that, or struggles that you had particularly? I know, Daniela, you were going to say something.
I can't open my quiz right now, but I know there was a question that after the fact, when I worked it out patiently, I got the same answer that the problem was. The numbers for the answer were the same numbers that the problem started with, and it did not make sense to me. But unfortunately,
Okay.
I can't open it right now.
So this example that we just did is kind of one like that, right? So, especially when you're doing metric conversions. So non-metric conversions won't always be this way, but metric conversions, whatever your coefficient is. So in the last problem that we were working on, the coefficient was 7.44, right? Whatever your coefficient is when you start, it's going to be the same coefficient when you convert. right? So the only thing that's changing in metric conversions, as long as it's only metric conversions, is the power of 10. Does that help, Gabriella?
It does, but even that didn't change. After I did it in sign out, after I transferred to sign out, I ended up with the same number,
So,
the same power.
so my guess is that you
I probably did something wrong.
potentially, yeah. So either your conversion factors were not correct, which is possible, or you put it into your calculator wrong. So if you're trying to do this in your calculator and you don't use the proper symbols, then that could also be problematic for you.
Okay, I'll have to send you a picture when I get home.
Cool. That
Because
sounds good.
I did it a couple of times after the quiz, you know, and I got somebody to help me out to make sure I was understanding it, and then we both came out with the same answer.
Okay, cool.
Thank you.
Yeah. So definitely, if you guys have questions after the fact, you can shoot me a picture. I'm happy to go over those with you. So Rochelle had asked us to do 8.19 times 10 to the positive 11 micrograms to kilograms. Sorry. Right? Okay. So again, we're going from, so this is kind of the opposite of the previous problem that we did, where this one is a really small unit, and this one is a really big unit. And this number, big or small?
Small.
Oh, no. 10 to the 11th. If you had that many dollars in your bank account, you'd be pretty happy about it.
I see it.
Yeah. So again, this is one of those things that it's really easy to get turned around with in scientific notation. But just remember, positive exponents, big numbers, right?
Yeah.
Negative
Yeah, I wasn't seeing that it was positive.
No problem.
Negative ones are the tiny ones.
No problem. That's good. That's cool. Sorry. So this is a huge number, right? But it's a huge number of small units, right? Is everybody still with me? Kinda? So, going from micrograms, not milligrams, right? Micrograms to kilograms, you are going from a small unit to a big unit, right? But you're starting off with a huge number of small things, right? So, do you expect the number to get bigger or smaller? The exponent, rather. What do you think?
Is it going to get smaller?
It is going to get smaller. Yeah.
Yay!
So this is kind of weird, right? But we expect that the actual exponent is going to get smaller here, right? So let's do our map. Again, we have microliters. We got to go to our base unit first, right? So now we're going from microliters up to liters, and then we'll go up to kiloliters. Oops, not grams. Oh no, sorry, I flipped it on us. We are in grams. Sorry about that, guys. There we go. Everybody okay with that? So now again, the tricky thing here is remembering the conversion factors for each one of these. So going from micrograms to grams, right? We know this guy is tiny and this guy is bigger, right? So where's the one gonna go? With the micro or with the grams?
The grams.
With the grams, yes. So for every 1 gram, how many micrograms do we have?
1,000 or 1,000,000.
1,000,000. Yeah, right? So milli, little m, is the 10 to the 3. That's 1,000, right? Like millennium. Micro is 10 to the 6th. Sorry. Everybody okay with that? And then going from grams to kilograms, right? Now this is the bigger guy, so we're going to put the one with it, and then we'll have 1,000 grams. Everybody okay with that?
Yes.
Any
That's
questions?
very helpful.
Cool. Any questions? We're okay? Okay, so now we just do our railroad track setup. All right, we've got 8.19 times 10 to the 11th micrograms. So if we're trying to convert from micrograms to grams, right, which unit do we want on bottom?
Microgram.
Micrograms. And so we have 10 to the 6th belongs to the micrograms, right? And then 1 gram will go up top. So micrograms will cancel with micrograms. And then we want to go from grams to kilograms, right? So what unit should go on bottom?
Grams.
So we have 1,000 grams for every 1 kilogram. Okay. So now if I have 10 to the 11th in my numerator, right? And all of my divisor, right, has these positive exponents. What do I do to combine the power of 10 on top and on bottom?
We can add those.
So if we're multiplying them together, right, then we can add them. So here we can add the 6 and the 3 to get 10 to the 9th, right? So now we have 10 to the 11th divided by 10 to the 9th. How do we combine those?
Subtracting.
Subtracting, exactly. So we would have 11 minus 9, right, would give us 8.19 times 10 to the 2 kilograms. Does that make sense, guys? So when you're dividing powers of 10, you're subtracting the exponents. When you're multiplying powers of 10, you're adding the exponents.
Is that our final answer right there?
Yep. Other
I'm
questions?
starting to think that maybe, yeah, you were right. Maybe that's what I did wrong.
Yeah, and I saw that it was pretty common. So, and the other thing is, um, yeah, so I think a lot of people had issues with the memorization. So, milligrams to kilogram step. So yeah, the main thing is, again, you don't want to go straight from, so you always want to make a pit stop at the base unit, right? You never want to go straight from above the base unit to below the base unit. It's always better to go from wherever you're starting to the base unit and then to whatever lower level or higher level you're trying to get to. Does that make sense, guys? So don't try and make one big jump.
Now it does.
Cool. But I mean, so, and it may seem like, oh great, well, it would have been cool to know this stuff for the quiz, right? But there's so much to learn in this, you guys, and you're going to have the ability to demonstrate this knowledge many more times because this is not going to go away, right? So dimensional analysis is a tool that we're going to keep using for the rest of the semester. We will take breaks with it, so the rest of the material for for exam 1 is going to be just conceptual periodic table understanding. So the dimensional analysis, the conversions, the word problems that we've done, that will be the extent of the math on this next exam. But going into the next exam, we'll start using it again, and then you'll see it again on the final exam, right? So, so just be aware that while it may seem trivial to like learn this stuff now, it's not, right? We got to pick it up somehow, right? So anything I can do to make that happen for you guys, I'm in.
Thank you.
Yeah. Did you guys are there not enough of these types of problems on the homework, or is it just that you have the conversion table handy when you're doing the homework and so you don't necessarily have to have it memorized?
Yeah, I think that's my problem.
Okay.
I think that I just need more practice and I just need to do more of the work, and once I keep on doing it and doing it and doing it, I'll finally get it and it will be drilled into my head and I won't get confused.
Perfect. So one of the other things that I'm going to do as soon as I have time is, I'll probably do it right now, is make the dimensional analysis quizzes all available for you guys to do infinity times. So it's just for practice, right? It's not going to affect your grade or anything, but that way you guys can actually like test yourselves in that same kind of setting. So I'll do that.
That's good.
Yeah.
That's good because I get like a little bit of text anxiety and everything.
For sure.
Yeah.
Super common. I know. And I feel like there's something about being in this remote environment that makes it even more stressful than it would be if you were in a classroom. Like at least when you're in a classroom, you're with other people that are doing the same thing and you feel like some solidarity. But yeah, I
feel by myself and it's
yes,
like,
stranded, right? You're just like,
yes.
Yeah, so I get it. I totally understand. This is a harder way to take a test for sure. So and I'm very empathetic to that. And again, if I really see that, that, students are still struggling with this, even after our next quiz, then, it's always possible that I might try and do a little bit of extra credit for you guys, right? But I don't want to make more work for you when you're already spending so much time trying to learn this. Does that make sense? So,
Professor, and
yes.
these retake what we can continue to practice with, are these going to also be under the tutorial?
No, they won't be.
Okay. Yeah, because that in itself is nerve-wracking.
Yeah, so I mean, at the Proctorio practice quiz is open for the entire semester. So I recommend that if you guys are really struggling with those issues, that maybe just give yourself like a 20-minute window before the quiz to try out the proctorio quiz, make sure everything's working right, because it is super stressful when something goes wrong with that right before you're about to start a quiz. But the practice, because it's I don't want you to have to go through that every time you're doing a practice quiz, because I feel like that might be, I don't know, do you guys want me to make them be proctorio based? Really? Okay, I can do it. Is that, yeah, Gabriella?
Well, it may kind of make sense because it would be more realistic.
Okay.
But, you know, we know that it's not going to affect whatever score we already got.
Yeah, I can totally do that. Okay, so yeah, I can make them proctorioed. I thought that would be more traumatic than helpful, but if you guys want it, I'm totally in. Yeah.
I think it's on an individual basis.
Well, and that's kind of the thing. So I have 3 versions of this quiz. So maybe I make like 2 proctorio practice and then 1 non-proctorio.
I think I want to start with the non-proctorio.
Yeah.
Get the answers right first. Don't you do the
Yeah.
problems?
Yeah, I can totally do that. Thank you guys. Those are great suggestions, because in my mind, I'm like, oh, I don't want to proctorio them any more than I'm already doing it. But if that's helpful for you guys, I am so happy to do that. Yeah, that's no problem.
No, yeah, I agree, because like on
Cool.
the last quiz, my husband was helping my little one on Monday with school, and he came and he's like, oh, I need this. I'm like, shh, I'm taking my quiz. Be quiet.
Yeah, so and maybe
That
just
helps.
maybe just taking practice tests in that in that environment will be will like de-escalate some of that anxiety for you guys. Yeah, I'm totally in. Let's
Yeah.
do that.
Yeah, I feel that will be better.
Cool.
Yeah.
Cool.
So
Go ahead.
always make a pit stop.
Always make a pit stop. Yes. You
Okay.
always want to go to the base unit. You never
Okay.
want to make the big jumps, right? And I would say that's true in general. So even when you're doing problems, conversions where maybe you're looking them up for the homework, something like that, I tend to lean harder on the ones that I can remember. Like, I can remember inches to feet, but I can't remember feet to centimeters, right? Do you know what I mean? So, like, for me, I'd much rather take more steps and have them be steps that I'm confident in. So, explain a quick example. Oh, of the pit stop. So the pit stop, Rochelle, that we were talking about is when you're going from, say, something like a kilo to milli, right? Is making sure that you go kilo to the base unit and then go base unit to the bottom, right? Or vice versa. So say you're going from milli, you would go to the base unit and then you would go to kilo, right? So you always want to make sure that you're making a pit stop at the base unit. Does that make sense? Cool.
You put it in numbers?
So,
Can you another sample with the problem again?
So this would be something like we were doing kilograms to grams to milligrams, right? You don't want to go straight from kilo. This is the no-no, right? Sorry.
So in our base units, don't we have like three different ones?
Mm-hmm. So we talked about grams. This could also be meters, right? Or it could be liters. right? Those are your 3 base units. So when we talk about...
Oh, those are my 3. What happened to the C?
C is not a base unit. That's centi.
Oh, okay.
Yeah. So meters, liters, and grams are going to be your main base units. Yes, I am, Daniela. Yeah. Cool. Yeah, I apologize too that some of this stuff is a little bit disjointed in terms of when and how you guys are getting these kinds of lessons. If people in question sessions don't ask these kinds of questions, sometimes if we've gone over a question that's similar, you might not have picked this up or had this question because you hadn't practiced it yet. But now, after doing some practice, you pick up these kinds of questions where you're like, how do I do that type of problem, right? So it's kind of frustrating when you're learning this technique because you don't know what questions to ask until you've encountered a problem, and then you're like, oh, I don't know how to do this type of problem, right? Or I'm not sure how to maneuver, with this kind of problem. So I think that we can say I'm pretty confident that most people's struggles were with the memorized conversion factors, not the conversion factors that were given, right? I think with the conversion factors that were given, you guys were relatively comfortable. Yeah? Cool. Cool, and that's great. I mean, if all it is being able to remember this kind of stuff, we can do that, That's in our wheelhouse. We can make that happen. But the best way to memorize things is not just staring at it, right? It's doing more problems. So doing lots and lots of these types of conversions.
Part of the problem also going to be which base unit to get in the pit stop.
So you're always going to know because it's like, so in the problems that we just went over, right? One of them, we started off with milligrams and it asked you to go to kilograms, right? So what's your base unit there?
Grams?
Grams, exactly, right? So it's already given to you, right?
I see.
Yeah. You just got to know that you need to make that middle jump, right?
Can we do, I had the first question on the quiz said 126 pounds, and then it gave the conversion from pounds to kilogram.
Mm-hmm.
I got that wrong. I multiplied it.
So 126 point... Oh, was it 12.6?
I think it was 12.6.
12.6 lbs to grams, right?
Mm-hmm.
Yeah?
Oh, yeah, mine was kilograms, but yeah.
Mm-mm.
No, it wasn't?
No.
Okay.
So the conversion factor that I gave you was that there's 1 lb for every 2.2046, something like that, kilograms, right? But you had to know that for every 1 kilogram, there's 1,000 grams, right? So that one wasn't given, but you still needed to know it in order to get all the way here.
Gotcha.
Right?
Okay, now I see what I did wrong.
Yeah.
Just by you saying that, I'm like, oh, duh.
No worries.
I know that.
But honestly, that's why I'm a crazy person when I write these out. I write down all of the information, and I'm so methodical about it, right? So I'm literally thinking, okay, is there a direct step that gets me from lbs to grams? Well, if I have a conversion factor that gets me from lbs to kilograms, then I know I'm going to have to make a pit stop, right? So it means I'm going to have to go lbs to kilograms, and then I can go from kilograms to grams, right? And then I literally write down my conversion factors for each one of these, and then I set up my railroad tracks, right? It's like a crazy annoying amount of extra work, but it's how I like systematize this so that I can't mess it up. You know what I mean? Because given the opportunity to like just look at this information that I'm given, right? Because this is all that you were given. It tells you that you're supposed to go to grams, but it's really easy to miss that when you just see this one conversion factor, right? Does that kind of make sense? So making sure that you're getting the whole scope of the problem, right? Does this conversion factor get me to where I'm trying to go? And if not, what's the missing conversion factor that I need, right? That's where the mapping is really helpful.
Okay, so doing it that way will make sure I cannot hopefully mess it up.
Yes, and the only other thing that you can do to mess it up is if you, the one other thing that I'll see is people won't write out the units in the DA, right? So, so again, I'm telling you from experience that I am the shortcut master, and I want to take every shortcut that I possibly can, and shortcuts in this are not helpful, right? So making sure you've got your lbs written in, you got your kilograms written in, kilograms to grams, right? And then I can fill in my conversion factors. I've got one of these guys for every 2.046. I don't remember exactly what it was. And then 1,000 of these for every one of those, right? lbs cancels with lbs, kilograms with kilograms, and then I just have to multiply through, right? This is kind of a good example too, again, when you get into non-metric conversions. Non-metric conversions are the only time that you're going to start off with a number that's going to end up, the coefficient that's going to end up being different in the end, right? Because non-metric conversions have all these weirdo numbers that we don't remember. But when you're just going from metric to metric, right, the coefficient will always stay the same. What do you think, guys?
Thank you.
Helpful? And I did put up another worksheet with some more practice. So, and then the answer keys are posted below it. So, so if you guys do need more practice, that's there. And then just a reminder, again, there is no quiz next week, right? So you guys have time to work on this, to refine it, to ask questions, all of that, right?
Thank you so much.
Of course.